Hello students, we are studying lesson number 5 and name of the lesson is the heat. So in this lesson, before this some points we have discussed, we have studied in that anomalous behavior of water, then dew point temperature is there, after that what is meant by humidity, what is meant by absolute humidity, again we have studied percentage humidity, after that white trail. So many points we have discussed. Now today we are going to study units of heat. What is the unit of heat? So in that particular, in case of the heat, there are two units. SI unit is there and CGS unit is there. SI unit is there and CGS unit is there. SI unit is there joule and CGS unit is there calorie. CGS unit is there calorie. SI unit is there joule and CGS unit is there calorie. So again we have to do the definitions of 1 calorie and 1 joule. So 1 calorie, 1 joule. What do you mean by calorie and what is mean by joule? So here first definition is there of the calorie, 1 calorie heat. First definition is there of 1 calorie heat. So in case of the 1 calorie heat, definition is the amount of heat necessary to raise the temperature of 1 gram of water. So amount of heat necessary to increase or to raise the temperature of 1 gram of water by 1 degree Celsius from 14.5 to 15.5 degrees Celsius. It is called as a 1 calorie heat. So what do you mean by 1 calorie heat? Amount of heat energy necessary, to raise or to increase the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. It is called as a 1 calorie heat. So again, what is meant by 1 kilocalorie heat? What do you mean by 1 kilocalorie heat? So in case of the 1 kilocalorie heat, amount of heat energy necessary to raise the temperature of 1 kilogram of water by 1 degree Celsius from 14.5 to 15.5 degrees Celsius is called as a 1 kilocalorie heat. So 1 gram, 1 calorie heat and 1 kilocalorie heat. So what is 1 calorie heat? Amount of heat energy necessary to increase or to raise the temperature of 1 gram of water by 1 degree Celsius from 14.5 to 15.5 degrees Celsius. It is called as a 1 calorie heat. Another thing is there 1 kilocalorie heat. So amount of heat energy necessary to increase or to raise the temperature of 1 kilogram of water, by 1 degree Celsius from 14.5 to 15.5 degree Celsius. It is called as a 1 kilocalorie heat. And another one relation we are knowing, 1 kilocalorie is equal to 1000 calorie. 1 kilocalorie is equal to 1000 calories. Next point is there, we have to remember, always remember in that. So if we heat 1 kilogram of water by 1 degree Celsius, suppose you will take 1 kilogram of water and you will heat that water at a different temperature range rather than or different than 14.5 to 15.5, then amount of heat required is different. Suppose you want to heat that water, 1 kilogram of water, and you want to increase its temperature by 1 degree Celsius, but you are taking different temperature range. So amount of heat necessary, it will be different. Amount of heat required is different, and therefore we have to specify or we have to define specific temperature range while defining heat. So you have to consider specific temperature range from which to which. For that you have to define that specific temperature range while defining that particular calorie or kilocalorie. So 1 calorie is equal to 4.18 joule. Next relation is there. This one also you have to remember. 1 calorie is equal to 4.18 joule. 1 calorie is equal to 4.18 joule. So another thing we have to study, and that one is there, you can say, introduction to the scientist. Introduction to the scientist. So in case of introduction to the scientist, James Prescott Joule, the name of the scientist is there, James Prescott Joule. So what about James Prescott Joule? So the scientist James Prescott Joule, so he showed that, first time he showed that kinetic energy of substances, or kinetic energy of particles of substance, that kinetic energy is converted into heat. Kinetic energy is converted into heat. So another one more thing he told, and whatever heat energy is there, heat energy can be converted into work. So James Prescott Joule, James Prescott Joule. So what he said, first thing is there, he showed that kinetic energy of particles of substance is converted into heat. It is converted into heat. Second thing is, he told energy can be converted from one form to another form. Energy is converted from one form to another form. And before this we have studied energy can neither be created nor destroyed. It can be converted from one form to another form, and total amount of energy in this world remains constant, in the universe remains constant. That one law of conservation of energy we have studied. But here energy is converted from one form to another form. Kinetic energy is converted to heat energy. And third thing, you can say, heat energy is converted into work. Heat energy is converted into, can be converted or is converted into work, is first law of thermodynamics. Is the first law of thermodynamics. So heat energy is converted into work, and it is the first law of thermodynamics. And another thing is there, for his honor, unit of energy is given as, or is considered as, joule. So for the honor of James Prescott Joule, unit of heat is considered as a joule. So these are the points related to the introduction to the scientist, and that one is the James Prescott Joule. So next thing is the next point we have to study, and that one is their specific heat. Next point we have to study, and that one is their specific heat. So what is specific heat? So when for understanding that particular specific heat, one short experiment is given or one activity is given, and with the help of that activity we will understand what type of specific heat is there, or what is meant by specific heat. So next point is there, specific heat. So in case of the specific heat, one activity you have to carry out, and that activity I will tell what you have to do. So first thing, you have to take one tray of the wax. You have to take one tray of the wax. Again you have to take 3 balls, one ball of iron, one ball of copper, and one ball of PB lead. Okay, so one ball of iron, copper, and lead. These 3 balls you have to take. After that you have to take one water bath. You have to take one water bath. So after this you have to heat all 3 balls. You have to keep into the water bath, and you have to heat these balls, and you have to heat it at constant temperature. You will increase temperature. Suppose you will heat up to the boiling of that particular water. So boiling point of water is there 100 degrees Celsius. So all 3 balls will have 100 degrees Celsius temperature. So one more time listen. Take specific heat in that activity is there. Activity. So take 3 equal balls of 3 equal sized balls of iron, then copper and lead. Iron, copper and lead. Second point, heat these 3 balls into water bath, up to 100 degrees Celsius. Third point, take a wax tray. Fourth point, remove these 3 balls out of water bath and place into wax tray. So one thing you have to do, suppose you will take one water bath, and in that 3 balls you have to add in that water, and then you have to heat it. So you have to heat it. Then what will happen? So temperature of this one, temperature will become 100 degrees Celsius. So all balls will have 100 degrees Celsius temperature. Initially, suppose this one is the iron ball, Fe, this one is the copper ball, and this one is the PB, lead. So like this way, and when you are keeping, suppose you will take one wax box or wax tray. Suppose you will keep, initially you will keep here 3 balls. And this one is the suppose wax tray. Here iron ball, copper ball, and lead ball is there. So initially temperature is there how much? 100 degrees Celsius. And after some time you will see this iron ball goes deeper into the wax tray. Then this copper ball goes intermediate, and this lead ball, this one is the iron ball, copper ball, and lead ball. So next one is the wax tray. So you can observe, you can see what will happen. Initially temperature of 3 balls is equal. Temperature of 3 balls is equal. When they are placed into the wax tray, then what will happen? They will penetrate into the wax tray because they are having heat. Temperature, initial temperature of all is 100 degrees Celsius, but here iron ball will go deeper into the wax tray. Then a intermediate depth copper ball will go in between, and a lead ball, it will go little distance into the, or it will penetrate little or very less in case of the wax tray. So why it is happening? This reason we have to find out. So what will happen here? So here initial temperature of 3 is equal, but it is happening like this, and because heat absorbed by these particular 3 balls is different. Even temperature will be equal, but amount of heat absorbed is different. Even temperature of these 3 balls will be equal, but amount of heat absorbed by these materials, these different material is different. Amount of heat and energy absorbed by this material is different, and this is called as a specific heat capacity. So specific heat capacity, you can tell definition of specific heat capacity. So amount of heat energy absorbed or required to raise the temperature of unit mass of substance or unit mass of an object by 1 degree Celsius. To raise the temperature of unit mass of an object by 1 degree Celsius, and it is called as a specific heat capacity. You can say specific heat only. You can say specific heat. So here, all of you give attention. See first, iron, copper and lead. If you are keeping hot objects into the wax tray, then iron penetrates deep into the wax. Again, copper penetrates intermediate, and lead penetrates very less into the wax box. So heat energy absorbed by these materials is different, and it is called as a specific heat. Or heat energy absorbed by that material, it is called as a specific heat. So next thing we have to see, definition will do. What is meant by specific heat? What is meant by specific heat? So here explanation also will write. Explanation. What is explanation? Initially, temperature of all three balls was same, that is 100 degrees Celsius, at the time of placing in wax tray. Second thing, iron penetrates deep into wax tray. Copper penetrates intermediately and lead penetrates very less. And third point is there, therefore amount of heat absorbed by different materials is different. Even though the temperature and heat, these are different concepts. Even though initially their temperature is same after heating into the water bath, but these or heat energy absorbed or heat capacity, heat energy absorbed by these substances is different. So we'll do now definition of specific heat. Definition of specific heat. Here only we write definition of specific heat. Definition. So what is the definition? Amount of heat energy required by unit mass of substance. Amount of heat energy required to raise temperature. Amount of heat energy required to raise the temperature of unit mass of an object. Unit mass of an object by 1 degree Celsius. Unit mass of an object by 1 degree Celsius is called specific heat. So amount of heat energy required to raise the temperature of unit mass of an object by 1 degree Celsius is called as a specific heat. Amount of heat energy required or necessary. So next thing is this one is the definition of specific heat. So specific heat for different object is different. Now next point is the unit of specific heat. And what is the unit of specific heat? It is what you can say, calorie per gram degree Celsius. Unit is there. Calorie per gram degree Celsius. Unit is there. Calorie per gram degree Celsius. Okay. And another thing is that specific heat is denoted by letter C. Specific heat is denoted by letter C, small c. Specific heat is denoted by letter small c, and unit is there, calorie per gram degree Celsius. Or kilocalorie per kilogram degree Celsius. So SI unit is this unit you can consider. So next point we are going to see heat energy or heat absorbed. So this one will drop. Specific heat capacity also you can say. if a specific heat of an object is C, specific heat of an object is C, mass of an object is m, mass of an object is there m, and change in temperature, or rise in temperature is delta T. Delta T, it is equal to T2 minus T1. T2 minus T1. And here, what is T2? Final temperature. And T1, initial temperature. So if specific heat of an object is C, mass of the object is there m, and change or rise in temperature is there delta T, that is T2 minus T1, then heat gain by the object, or heat of the object, Q is equal to it is equal to m into C into delta T, or you can give here heat of that object is equal to mass of object into specific heat of object, and here increase in temperature or rise in temperature. So this formula you have to remember. Another thing is there, next thing, if specific heat is there C, mass of object is there, mass of object is m, and decrease in temperature is delta T. Now delta T, delta T is equal to T1 minus T2. So what you are doing, T1 is there initial temperature, and T2 is final temperature. So delta T, T1 will be higher, T1 will be maximum, T2 will be less. So therefore heat lost by the object is equal to Q is equal to, you can say, m into C into delta T, or in words you can write heat lost is equal to mass into specific heat into decrease in temperature. This one also you have to remember. So this These two concepts you have to remember. After this, next point we are going to study, and that next point is their heat exchange. Next point is their heat exchange. We'll draw a diagram of it. So next point is the principle of heat exchange. Next point is the principle of heat exchange. And in case of the principle of heat exchange, one short activity is there, and in that what you have to do, you have to take thermally isolated box, or you can tell heat resistant box. One box you have to take, heat resistant material box you have to take, and in that you have to take hot object and cold object, and these two objects are kept in touch with each other. These two objects are kept in touch with each other, so they are in contact with each other. One object is their hot, another object is their cold. So in case of the hot object, hot object loses heat and cold object accepts heat. So hot object will lose the heat energy and cold object will absorb the heat energy. One is losing energy and another one is there gaining energy. So heat exchange takes place between hot object and cold object. And that particular heat exchange will take place till temperature of both objects will become equal. That up to which state that particular heat exchange will take place, hot object will exchange or hot object will lose energy till temperature of both objects will become equal. And when temperature of both objects will become equal, then exchange of heat energy will not take place. So next thing is that here one object is losing heat energy. Suppose the hot object, how much energy is lost by hot object, and that much energy is gained by cold object. So how much energy is lost by hot object is equal to how much energy gained by cold object, and it is called as a, and this box, these two objects are kept into the thermally isolated box or heat resistant box in that. So principle of heat exchange. What is the principle of heat exchange? Amount of heat energy lost by hot object is equal to amount of heat energy gained by cold object. It is called as a principle of heat exchange. And here, suppose first point is there, two objects are placed into a thermally or into a heat resistant box. That is, one object is hot and another is cold. One is hot, another one is the cold. Second thing, exchange of heat takes place. Exchange of heat takes place between hot and cold object. Hot object loses heat and a cold object gains heat or accepts heat, gains heat. Fourth point is that exchange of heat takes place. Exchange of heat takes place. Exchange of heat takes place till temperature of both objects will become equal. And therefore we are going to write here principle of heat exchange. Principle of heat exchange So what is the principle of heat exchange? Principle of heat exchange, in that amount of heat energy, amount of heat lost by hot object is equal to amount of heat gain by cold object. So this is principle of heat exchange. So amount of heat energy lost by hot object is equal to amount of heat gain by cold object. You can write here heat energy. Here also you can write heat energy. Amount of heat energy lost by hot object is equal to amount of heat gain by cold object. So after this, next point we have to study, and that one is there exchange of heat and calorimeter. Next point is there measurement of specific heat and calorimeter. So by mixing method. Next point is there. So this principle you have to remember. Next point is there measurement of specific heat and calorimeter. Measurement of specific heat and calorimeter, and measurement of heat by mixing method you have to study. So we'll draw diagram first, and first I will explain what is meant by calorimeter. What is meant by calorimeter? So calorimeter in case of calorimeter, one heat resistant box is there. Suppose one heat resistant box is there. In case of the heat resistant box, inside one copper vessel is there. Heat resistant box is there. Heat resistant box. In that resistant box. copper vessel. Copper vessel. This one is the thermometer. This one is the stirrer. Here it will be insulating material. Okay, and this one is the calorimeter. So suppose one hot object you are placing there. Hot object. So this is calorimeter. So what is the calorimeter? Calorimeter is one device, and that calorimeter is used to measure amount of heat. So to measure amount of heat exchange, for that calorimeter is the device, and in that we can measure the specific heat. So in this one heat resistant box is there. Calorimeter is the heat resistant box. In that one copper vessel is placed. What is there? In that one copper vessel is placed. One copper vessel is placed, and in between copper vessel and this outermost boundary, in between this, air is there or wool is there. Air or wool is kept, because air or wool, these are bad conductors of heat. So heat will not be exchanged with surrounding. So in this system, heat is not exchanged with surrounding, or heat is not allowed to come inside, or heat is not allowed to go outside. So in this, one thermometer is fixed to measure the temperature. Thermometer is fixed to measure the temperature. One stirrer is there to mix that particular mixture or to stir that mixture, and suppose one hot object is placed there, and here water is there. Suppose water is there. So like this way. So this system is thermally isolated. This system is thermally isolated, and in this, what will happen now? Heat energy, hot object will lose heat, and cold object, that is water, will gain heat. So, and that heat lost by hot object, it will be gained by water, as well as it will gain by the copper vessel. So heat will be absorbed by water, as well as heat will be absorbed by copper vessel or calorimeter, you are saying. So here also you can apply principle of heat exchange. You can apply principle of heat of exchange. So next point, which one is there? Measurement of specific heat. Measurement of specific heat, and a calorimeter. So in this, how to measure that particular specific heat? Suppose initial temperature you have to note down. Before placing hot object, you have to note the initial temperature, and when an exchange of heat will take place, then temperature will change. Hot object will lose heat energy, and cold objects will get heat energy. And heat lost by hot object, iron ball or any object, is equal to heat gained by water, as well as heat gained by calorimeter. So here also you are applying principle of heat exchange. So first thing is the calorimeter. It is a device which is used to measure amount of heat exchange. It is used to measure the amount of heat exchange. It is a thermally isolated box. second thing is there, when hot object is placed, when hot object is placed into calorimeter containing water, then heat lost by hot object is equal to heat gain by water and calorimeter. Calorimeter means this copper vessel, calorimeter. So you can consider, you can take like this way, heat lost by hot object is equal to heat gain by water plus heat gain by calorimeter, copper vessel. So, and here this one also you can do, this one also you can explain by taking terms. Okay, so what you can say, suppose Q hot, it is the total heat, it is equal to Q of W plus Q of calorimeter. So total heat is equal to heat of hot object is equal to heat of water, heat gain by water and heat gain by calorimeter. Like this way you can do. Suppose you can consider specific heat of hot object, or after this we will take. So this one is the equation. Specific heat of hot object will be there, or in the next part after correcting this one I will I will show that one. So listen, hot object, heat of the hot object is equal to heat gain by heat lost by hot object is equal to heat gain by water plus heat gain by calorimeter, or you can say total heat Q is equal to Q1 plus Q2. This one also you can write. So heat lost by hot object is equal to heat gain by water plus heat gain by calorimeter, or Q is equal to Q1 plus Q2. Q is equal to Q1 plus Q2. And in the form of equation also you can write. So we'll write like that one. So this one I will rough. So we'll take in the form of equation. Suppose mH will be mass of hot object, MC or CH specific heat of hot object, and delta T is temperature change. So therefore total energy Q is equal to Q hot is equal to, you can write mH multiplied by CH multiplied by delta T. Suppose this is equation number 1. Then heat of water or heat gain by water is equal to, suppose you have to suppose here, is equal to mW mass of water multiplied by Cw specific heat of water and multiplied by delta T. Delta T increase in temperature. So mW mass of water, then Cw specific heat of water, and delta T increase in temperature. So this one, suppose this one Qw you can take. Qw is 2. And next thing is the heat gain by calorimeter vessel. So here you can take QC is equal to MC multiplied by CC multiplied by delta T. So MC mass of calorimeter, that is copper vessel inside. CC specific heat of calorimeter, specific heat of copper you can take. And next one is the delta T, increase in temperature. Therefore, suppose this one is the equation number 3. So from 1, 2 and 3, what you can write? Q hot is equal to Q W water plus Q C calorimeter. So you can write finally, therefore mH multiplied by CH multiplied by delta T is equal to mW multiplied by Cw multiplied by delta T plus MC multiplied by CC multiplied by delta T. Like this way you can find out. So these are this one is there according to principle of heat exchange. This one is there. So like this way, this lesson is over. This lesson number 5 is over.